Vector database in plain English. Hello everyone, and welcome to our channel. Today, we will discuss a little about vector databases. Are you ready? Great, then let's jump right in. Imagine you search best small cat for an apartment, and the results include kitten care, indoor pets, and even quiet breeds, even if those exact words are not in your query. That feels smart because it understands meaning, not just letters. That is semantic search. Today, we will see how vector databases make that possible and why RAG, retrieval-augmented generation, depends on them. Why keywords alone break. Traditional search matches letter to letter. It is great for exact phrases, but it is brittle. If I say feline and you search cat, a pure keyword engine can miss it. Synonyms, wording, and context trip it up. Modern AI flips the problem. Instead of asking, did these two strings match, it asks, do these two ideas mean something similar? To do that, we turn language into numbers. Embeddings in plain English. An embedding is a long list of numbers that captures the gist of a piece of text. You can embed a single word, a sentence, or a paragraph. Think of a giant map where related ideas live near one another. Cat, kitten, and pet cluster together. Dishwasher and detergent sit in another neighborhood. When you type a question, we embed your question into that same map. Then we look for the stored texts that sit closest to it. Closest on the map usually means closest in meaning. This nearest neighbor step is the heart of semantic search. Picture this. You type, best vacuum for a small apartment. We embed that sentence. On the map, it lands near texts that mention compact, quiet, and easy to store. It does not land near outdoor leaf blowers, even though blower and vacuum both move air. We ask the vector database for the closest passages. It returns reviews and guides that describe small size, low noise, and quick cleaning. When you read them, the words may be different, but the meaning lines up with your intent. That is the power of nearest neighbors. It follows meaning, not just matching letters. What a vector database actually does. Where do we keep all those vectors, and how do we find the nearest neighbors fast? That is the job of a vector database. It stores the vectors and it builds indexes that make search quick even at a large scale. Under the hood, it uses clever shortcuts, so it does not compare against every single vector. For example, some indexes organize vectors as layered graphs so the search can hop toward the right neighborhood in a few jumps. Others split the space into buckets and only search the most promising buckets first. You still keep the original text documents on the side, but the index that powers retrieval runs on vectors. The result is a fast similarity search that can return good matches in milliseconds, even across millions of chunks. If you have under 100,000 chunks, a simple flat index can be enough. It compares more items, but the set is small. If you have millions of chunks, use a graph-based index like HNSW for fast lookups with high recall. If memory is tight, try a coarse quantization method like IVF to reduce the search space first, then refine inside the best buckets. The right choice also depends on write patterns. If you insert new data constantly, you want an index that handles frequent updates without long rebuilds. If you load once and search many times, you can afford a heavier index build up front for very fast queries later. Why RAG fixes hallucinations. Language models are pattern machines. They complete text based on training, not on your private facts. When a question needs specifics, the model can sound confident and still be wrong. RAG reduces this risk by pulling real passages first and asking the model to write with those passages in view. Think of it as open book instead of closed book. The quality of the answer now depends on the quality of retrieval, which you can measure and improve over time. RAG step by step. Now, let us put it together with RAG, i.e. retrieval-augmented generation. Language models are great at writing, but they can make confident mistakes if you ask about facts. RAG helps by pulling in your real sources before the model writes. Step 1. Take the user question and create a vector. Step 2. Ask the vector database for the top matches. These are the passages that mean something similar to the question. Step 3. Send the question and those passages to the language model as context. Now the model writes with references in the table. That is how chatbots can quote your documents, how help centers can answer policy questions, and how search experiences can cite sources. Quality dials that move the needle. To raise answer quality, focus on 4 dials. 1. Chunking. Split your documents into pieces that are easy to match in meaning. 200 to 500 tokens is a common sweet spot. Too big and the meaning gets diluted. Too small and you lose context. 2. Metadata filters. Pair vector search with structured filters like date, author, product, and language. This narrows matches to the right slice of your data. 3. Reranking. After you pull your first set of candidates, run a second pass to reorder them by relevance. Even a smaller model can improve the final list. 4. Freshness. Re-embed when content changes. New or edited pages need new vectors. Fresh vectors keep retrieval sharp. Hybrid search. Keyword plus vectors. Keyword filters and vector search are not enemies. Use vectors to find meaning, then use keywords to slice the set. For example, find passages semantically related to refund, then require the word policy or the product name to appear. Hybrids shine when you have regulated terms, product codes, or dates that must match exactly, but you still want the flexibility of semantic ranking around them. In practice, many teams do. Vector retrieve, keyword filter, then re-rank. Costs and common traps. Embeddings cost money to compute. Storage grows as your library grows. Bad chunking or missing metadata can bury the best answer. Also, remember this. Vectors capture meaning, not truth. If your source material is wrong or outdated, retrieval will faithfully bring it back. Always log queries, track which documents get clicked, and measure whether answers actually resolve the question. A mini case study. Imagine a support team with 10,000 help articles and release notes. Before RAG, agents and customers searched with exact words and skimmed many pages. After RAG, the system embeds all articles and release notes, and it embeds each user's question. The vector database returns the closest passages, then the model drafts an answer that quotes those passages. With chunking tuned to about 300 tokens and a date filter set to prefer recent releases, resolution time drops, and hallucinations fall because the model is grounded in the retrieved text. The team reviews unanswered questions weekly, adjusts chunking for the problem areas, and re-embeds any pages that changed. Over time, the system gets faster and more accurate. TLDR. Here is the simple summary. Embeddings turn meaning into numbers. Vector databases find nearby meaning quickly. RAG stitches the right passages to the question so the model can answer with evidence. In the next video, we will compare keyword search and vector search directly, and we will show why a hybrid approach using both together usually wins. If you liked the video, then click the like button and subscribe to our channel for more informative content. Also, don't forget to turn on the notification bell so that you don't miss our next upload.